it will be available and posted in our YouTube channel after the presentation. The presentations or the slides for this webinar will be sent via email after the session. And for the questions, you can always drop your questions in the chat or turn on your mics during the Q&A session at the end, or you can just put your questions in the Q&A box. And of course, we value your feedback. So if you can share your feedback or anything that helps to improve, that'll be great for us. I will start the presentation of our guest speaker today, Ms. Katerina Dimovski, Project Manager for Energy and Sustainable Services. Just like a short bio, she's got a master's in mechanical engineering and a bachelor's in electrical engineering. She's Energy Manager, ISO 50001 and 40001 lead auditor and sustainability expert. So she's experienced energy manager specializing in ISO 50001 implementation and auditing, industrial energy efficiency and sustainability strategies. Project manager for energy and sustainability at Georgia Tech until October 2025, leading energy assessments, helping manufacturers navigate toward achieving their carbon emission goals. Previously served as national energy expert in North Macedonia and as an energy manager in energy-intensive steel manufacturing industry, driving decarbonization and process optimization initiatives. So from now on, Katerina, welcome. Thank you for joining us, and the stage is yours.
Well, thank you, and thanks for the kind introduction. In today's session, I will be giving a short overview and introduction to how climate change, GHG, and energy is correlated. So if I may start, the greenhouse gases, what we know are the ones that are trapped in the atmosphere, and those are the ones that drive the climate change according to international climate change agreements like Kyoto Protocol and Paris agreements. Those gases are categorized as carbon dioxide, methane, nitrous oxide, and other fluorinated gases. So whatever is exhausts from or outputs from the process, manufacturing, and maybe some other types of processes that are that falls under these categories will be considered as greenhouse gas. Each of these factors have each of these gases have a different level of energy intensity embedded in them. So it will contribute to the greenhouse gases at a certain level. Out of the total greenhouse gas emission in the Earth atmosphere, around 75% comes from manufacturing and energy generation. So whenever electricity is produced to get to an end user, whether it's from for coal and gas sources, that's what's contributing to those greenhouse gases directly. Just for like states is all of the states in the United States of America would have a little bit of different energy profile. So I used, for example, South Carolina, that's where I'm currently located in. For 2023, the profile that U.S. Energy Information Administration states is around 55% coming from nuclear, 22% coming from natural gas, 15% from coal, and the rest will be renewables like solar, hydro, and biomass. What will that mean is that there will be a different coefficient from greenhouse gases intensity, or that tons of CO2 embedded, than if we compare to our neighboring state, North Carolina, that is 39% out of the electricity is coming from natural gas, 30% is nuclear, around 11% is coal, and 13% is coming from renewables. So what will this mean for a manufacturing industry standpoint? Like, how would you consider for the greenhouse gas content? You basically would like to look at the consumed electricity and the location you are currently in. Maybe in the end of your bill, you'll have some explanation of what is the energy content of the grid. and you can transfer that number to a tons of CO2 emission. Another way, aside from the electricity content, is the how much natural gas or methane or another gas was combusted in the process directly, and you have a finite number of your GHG input. Also, fossil fuels are used for generating electricity, and like I said, the industrial operation will be most of that, 75% of the total GHG. So how do we tackle this road? By finding our most carbon intense process and reducing that or optimizing their efficiency, optimized use for that. So like I mentioned in the previous slide, there is a link between the energy consumed and the carbon emitted. Most of the carbon emissions are coming from energy generation and consumption. So from the generating standpoint, whatever energy had to be made to be consumed in the final user, like let's say a manufacturing industry, there are some losses on along the transmission line, and is considered those losses to be like for 1 kilowatt consumed in the manufacturer, around roughly will be 3 times more needed to be produced at the source. So optimizing and reducing energy use to a certain level, like of course we don't want to affect the production process, but let's say smart usage of electricity will directly cut the CO2 emissions. Once the consumption is optimized, we can focus on cleaner energy source to amplify the emission of the effect of the reduced impact. And it's advisable to monitor the energy flow in the high energy intensive areas. While if you want to have more strategic approach towards energy management, it is advisable to establish some energy performance indicators. There will be our link between the energy and carbon. By that mean whatever is the base load of energy used in the facility will be on one side, and whatever is the energy needed for producing the output will be directly correlated to some variables that are going to affect that consumption, and that's going to show us how to are we on the right track to optimizing and improving the performance of that production part. Planning for energy will definitely help. Quantifying what we don't measure, we cannot improve. And whenever we start to find the right way to measure and establish those performance efficiency metrics, will give us the indication if we are on the right track or not. That's why we always advise to, if you wanna, manufacturers wanna tackle the energy area, it's advisable to have a strategic approach towards energy management systems, and that is by not necessarily certifying by ISO 50001, which is the standard that supports the energy management system, but overall just implementing the plan, do, check, act cycle, and having a plan for energy will get you on the right track towards performance improvement. So an energy management system will be a systematic approach towards improving the overall performance, and is based on ISO 50001. It will help integrate energy efficiency into daily energy management practices. It will help with like there is a planning part, there is checking, doing part, then checking, and continual improvement, which is really important because energy is not just projects you do it once and it's out of the table. Energy is always continual improvement and keeping your significant energy uses on the loop of what can be done and improved further. Energy management systems also focus on reducing the wasted energy, like energy that is not really essential and needed for the process, and optimizing the resource use, like not only electricity, it's every energy that are in the scope of the factory. By implementing this energy management system, you will have a list of significant energy use that like the equipment that can be improved energy wise, or the one that can be optimized with the consumption. And with that, you can make this is a really important part, informed decision on how to strategically approach the energy, because we've been on sites where sometimes it's challenging to see what is your really significant energy use. Sometimes it can be the HVAC unit running on the rooftop of the facility and that it's really out of the site. Or sometimes it can be some chiller system that is really not maintained adequately, or maybe an air compressor system that is that has some air leaks that could potentially be improved. And I've been in facilities where the compressor set point was way over what is needed. So those are like small minor tweaks that could really change the energy impact of the whole production site. And how will this help decarbonization? So by simply thinking, having energy on your daily task, you will eventually see the benefits of it. Like energy is not a simple plug and play solution that can be incorporated everywhere. It's even if it's the same facility and has two production plants, they will have minor changes or bigger changes in the carbon footprint. So that's why it's advisable to look at each facility as autonomous and try to identify the energy used across the operations. So whatever is input on the system and whatever is used for producing the final product. And having that will start the process of establishing continual improvement, like we said, with better planning and execution of our strategies, and checking for continual improvement in the energy side. So let's say if we have air compressor system that is not really working on commissioning stage or has some air leaks associated to it, that air compressor will be running continuously to get to the certain pressure. And let's say that pressure is not really needed in the process. We are just the equipment is running and just building up to a certain level just to satisfy a certain air leaks in the process. So that energy is consumed at the site and produced around 3 times more on the electricity production plant, and then really not used for any production output activity. And whatever can be saved, let's say at the production site, means less wasted energy on the manufacturing side as well. By doing those optimization, we will align our energy and carbon goals and lower the carbon footprint. And of course, the real important part, we can find a measure of a number to measure those targets and savings along the way, because savings are really challenging to measure and hard to demonstrate what you actually saved. And that's why having the right target and metrics will make things more convenient on the energy saving side. If the manufacturer is interested to go all the way to implementing ISO 50001 and getting certified on it, it will definitely it's a little work upfront, but it will get you on the right track to proven reduction in energy costs, which is really important, and greenhouse gases emission. Cost is a really big part of ISO 50001, but it's not the essence. The main focus will be lowering the consumed electricity or like consumed energy that either it's in megawatt or pounds, tons uh, of the main primary source energy, and then that with lowering and optimizing that, the greenhouse gases content will be lowered as well. Whatever is not consumed and optimized use, it will evidently lead to lower energy costs. And of course, with fluctuating prices of energy, that will just make more stable basis for production. It will help enhancing compliance with climate and other sustainability regulations that are going on. It will, of course, increase operational efficiency and competitiveness of the market. Back in the steel company where I worked, energy was a really big part. Electricity was a big part out of the price of the final product, and having that reliable, let's say, price for one of the resources in the process was really important to make a stable output, like final product. It improves corporate reputation and, of course, stakeholder trust, especially in European countries. Will be way more into ISO 1450001, and because they know the value, the added value that comes with some certification. Of course, there are some other measures that contribute to that as well, but ISO 50001 is interestingly one of the systems that requires improvement of the system, both system and performance improvement. So that is one of the standards that requires actual improvement of the performance output. Also establishes groundwork for better reporting on environmental and sustainability goals, and maybe part of it will add a bit of life cycle analysis to every product purchase for around the significant energy use. Well, I would say the hardest part in implementing ISO 50001, the most challenging, will be creating the culture of sustainability across the organization. It may change some dynamics on how things were looked energy before and after it was implemented, but of course that will lead to a greater cost and put the company on the right track for towards improving the energy performance or lowering the energy consumption. It's really convenient that ISO doesn't specifically set the goal, but it requires for the company to establish some energy metrics, targets, and to hold them accountable to achieve those. One of the key components of putting an energy management system together will be having energy policy. And I would really like to point this out, top management commitment, because without having the top management on the energy side, it's going to be really hard to implement the system, and it will be just the energy manager filling out paperwork and doing the numbers. But if you want to really make the system work, you need the top management commitment and support, especially to the energy team, to achieve the objectives, targets, and action plans. Energy policy and the top management is one part of the system. Then all of the energy team will have to work together towards energy planning for energy efficiency. And that will be identifying the significant energy uses. So like I said, that can be the equipment that consumes the most energy, or the equipment on the site that has the most opportunities for improvement. On some site that can be changing the lighting to LEDs. So that's why the scope of an energy system can be very broad and vary from changing like lights, or maybe some process optimization strategies, because back in the steel company, I'm coming from, like I said, energy intensive industry. Whatever we did with lighting or some other areas in the plant, it was really hard to demonstrate that we saved something and show our energy performance improvement. And everything was around our significant energy uses, which was the electric arc furnace. It used gas and electricity for melting the scrap and producing plates, and that was really around more. And our energy strategies were more around the input of the process optimization and around our ECU. So that's why the energy planning will be very custom to the company, and setting those objectives, targets, and action plans will also be very tied to the company's goals. Another part that is interesting, that is really vital in the ENMS system, is how does the company establish competence and awareness for the ENMS? There has to be some training going around, so we know what are the ways that competence is established, and everyone has to be aware of the energy system. As part of the energy management system is having the right monitoring in place and monitoring and measurement system. Like I said, depending on the process dynamic, it can be done on monthly basis. Maybe having those invoices, monthly invoices, will work for some. And for some more dynamic processes, like more detailed metering is advisable. And the final checking part will be the internal audits and management review for continual improvement. With these, we want to check if the system is functioning well, and how is management committed to achieving those objectives, target, action plans, and what is the output of the system? Like, are we on the right track, or if not, what can be done to be improved down the road? And like I mentioned upfront, this efficiency will give us the path to decarbonization, or having a better strategy when we want to attack what can be improved to get to our goal. From experience, I've been on site. They were struggling with achieving their greenhouse gas goals, and they were mainly focused on the production process, which is normal. Every manufacturer's primary goal is to get the product out of the door. So whatever they see is what they have on the production site. And it was really cold in the rooms, like the rooms were air conditioned. So when we did an energy balance, it turned out that the 60% out of the total energy consumption was coming from the HVAC. So basically, whatever they did in the process would be really hard to get them to the estimated goal, to their goal. The only thing that they could do is just raise the temperature a few points, and they will achieve their carbon goals. So that's why it's really important to know and plan for efficiency, so you can pave the right way and do the right steps on the decarbonization process. The path will be with reduced energy waste, like reduce the energy that is not needed for production. Electrify as much as possible, and then switch to renewables. Those renewables will have very low close to zero greenhouse gas CO2 equivalent tons embedded in it. Optimize the operation as much as possible. Of course, sometimes it's hard to make the old equipment run together with the newest achievement, but to a certain extent, some optimization of the operations are possible without making a significant cost. Recovering and reusing of all waste heated or energy down the process, and of course integrate these strategies with a current management goals and some net zero strategies if they come along the way. So case studies and results, these are very general from internet. I mean, of course, we are working with companies and on sites, but general savings will be that the companies that are certified with ISO 50001 see 10 to 30% in energy savings. And I would say the higher the energy impact of the company, those numbers will be less, but of course the tons of CO2 will be way more. So like I said, in the numbers we use in energy intensive sector, these 30% will not be achievable. It will be way lower, like one digit number. But even if you see 1 or 2% for an energy intensive industry, that's a lot of CO2 saved. Like beverage, cement, automotive industries will maybe able to demonstrate a higher savings, or let's say some less dynamic processes are more easier to handle. Usually energy intensity and emissions are expected to drop 2 to 3 years after implementation. And of course, implementation is not a simple short project. Like I said, it may take some time to get the company on the right track and establish the right performance and metrics. And that's also very dependent on how much past data the site has. ISO 50001 is really ready and helpful can be integrated with other ISO standards like the environmental or 9001, whatever, to what extent the manufacturer will be interested in incorporating all the ISO structure under one integrated system. This is one demonstrated and foolproof path to achieving some corporate net zero or other carbon related goals, just because it allows that strategic continual approach. Of course, it's not everything is not as bright as it sounds. There are some challenges along the way. From my personal past experience, I would say the behavioral change will be the hardest challenge to overcome. But there are some other challenges as well, like data collection and establishing a baseline. If the baseline is established way far in the past, it's going to be hard to see, and the processes change. Let's say if it used to be like one shift and then the production expanded to 2 or 3 shifts, it's going to be harder to establish an electricity baseline consumption, and then harder to demonstrate the savings as well. Of course, it requires communication between multiple levels of the organization, from top to the operators, and requires some management commitment and workforce engagement. The easy and both the solution and challenge can be if we want to integrate more than one system together, but then it's convenient to have one integrated system where the auditing will go, or certification can go in just one cycle. It helps with overcoming short-term thinking with a longer-term vision. And I think we've all been there when the initial price of the part of the equipment of the product is the main factor, whether we're going to acquire that part or not. But if we plan with longer term, like how is that going to affect energy related, and we do a life cycle analysis of that equipment, we can make a better informed decision on whether we want to buy what is the most convenient at the moment, or we want to make like a longer term energy strategy. It requires continuous training and competence building, because we want to make sure that the people that are working on the site are really aware of their impact of the energy management system, and they can contribute most effectively to it. Like I said, for having a single energy intensive ECU, of course, the operators on that significant energy use will have the most direct impact to the energy performance of the equipment. And the more digital tools that we can use for monitoring and analysis, the more successful implementation of the system we'll have. So that's not essential, but it's a convenient tool to use. And of course, it's not just data collection. We have to find the right way to present the data, like to monitor and analyze, and to get the best outcome of it. So by having structured approach to energy, we can make informed decision and measure our decarbonization. It will link efficiency, renewables, and innovation process in the process under one framework, and that's going to lead to continual improvement as well. It can help align with some national or global carbon strategies, whatever the company plan for the future is. And of course, it's going to promote resilience to energy price changes and fluctuation, which is really huge. Plus, nowadays, of course, it's going to help companies lead in sustainability transformation and a low carbon future. So I really enjoyed so far. I would like to hear your comments, or if you have any questions, please feel free to ask. If not, Pablo, yeah,
Yeah,
you
thank
can
you, Katerina,
take
for
over.
the presentation. Let me see. We don't have like any questions in the chat or in the Q&A, but maybe I can ask one about it. Is like when you are implementing the ISO 50001, is like how far should the company extend like the boundaries of their implementation? Let's say, because with a lot of companies that I've been talking to, is like they are confused on whether it should be like an internal process or should be related with suppliers or just like providers and everything. So I guess if you can just explain us more about how to just like
Yeah, well,
organize it, that'll be
ISO
great.
ISO gives clear directions on that. Like everyone working under the company umbrella has to be informed of the ISO, and like the suppliers will have to be aware that the company is having some energy considerations, and of course the contractors working there have to be informed to a certain level. And but how far back we want to go, like in calculating the energy baseline and the other establishing those energy performance, it's very up to the organization and whatever works for the company. For some, let's say, less dynamic processes, maybe we can compare further down the road, but let's say for more dynamic or expanding manufacturers, we wouldn't want to compare with some numbers so far back. So if we want to make the right baseline, we have to plan for, we have to keep in mind those changes that might have happened along the way. Like COVID changed a lot of the energy part for a lot of manufacturers. So if the company had some challenges in that period, it's convenient to like skip and go back a couple of years and try to establish some baseline around it.
Yeah, thank you, Katerina. I guess
Sure, thanks.
another question that usually arises among the manufacturing facilities will be, once you uh, selected your significant energy users, then you will organize by the ones that is affecting the most, and then you will have to tackle every single one of them, or just like is there a threshold where you say like, okay, I reduce like this amount of energy, that'll be great, so I just don't have to look for the other ones.
Well, no, that's a thing that ISO says. Once you establish the significant energy uses, you have to do multiple things around it, like as demonstrate find the performance indicators around it, and find the people that are working on that, like who can impact that ECU. So there are a couple of things around that ECU. But what is the criteria for defining for what makes an ECU a significant energy use in a company? That's also defined by the organization. So once the organization defines that a certain equipment is a significant energy use, then another calculation methodology and another procedure follows around that ECU, like requirements of ISO. But if we it's totally okay if the manufacturer start with one and then expand from there. Like if you have an equipment that you want to pay the most focus to, it's totally fine to start, let's say, with whatever consumes the most, and maybe further down the road expand to another significant energy uses. But once you define that those are the significant energy uses, let's say if you have multiple or 10, then there are other things related to those that must be done.
Yeah, thank you, Katerina. And I guess since you mentioned that this energy management system is a continual improvement, so I guess if the company just like keeps lowering their energy emissions, they can just like find new significant energy users and then keep optimizing them. So that's, I guess that will be one of the big benefits of this 50001 energy management system, right?
Yeah, it can be, not necessarily. We can stay with the same not with the same significant energy use and then try to improve on that as well. And of course, some downsizing, like some improvements, can be done only to a certain point before we need to think of an investment or anything else. But there are other ways of establishing a baseline, and it's not always a percent of savings. Like we cannot improve 10% every year, right? So ISO doesn't really requires us to doesn't tie to a certain number. It's the company defined what energy improvements expects to achieve, and then it has to demonstrate those achievements. So if it wants to, if the organization would like to set another ECU, that's fine. But if even if we stay with the same significant energy users and try to find better ways to produce or save, that's perfectly fine too. But like there are some guidelines in the standard where once we define how we're gonna establish those significant energy uses, we have to follow that process too.
Yeah, thanks for the answer, Katerina. Let me see. We don't have like any questions in the chat or in the Q&A. So yeah, I guess just like for closing this webinar, I will show like more slides in here. Like for example, interested in receiving technical assistance, we as the center can offer a free energy assessment. And as Katerina is experted with the topic in ISO 50001, it could be a great opportunity to take for a company. So we can help with the implementation or like first steps of the 50001, and also like offer you like, you know, like the pollution prevention recommendations that we usually propose when doing this one. So it's kind of like an audit style that we will do it in your facility. You don't have to shut down any of your equipment. We are just gonna walk in there, gathering data and checking some the energy consumption and everything with our tools. But then we can just like provide kind of like our internal findings, and this will help, of course, to develop a strong 50001 energy management systems. We have our expert in here, so if anybody is interested, please let us know. You can always text to the center, and here, let me see, we have like some upcoming events. We have an online course with Dr. Languri on Friday on December 11th and 12th. It's gonna be all of these future events are online. ETAN's course will be industrial energy efficiency improvement. Our next webinar will be like also in December with Dr. Duba, professor of engineering here at ECU. And in February, we're gonna have like the a technical training course about the energy management system and auditing principles for manufacturers. So please, if you are interested in any one of these, just like scan the QR code and then you will find all the information and registration links. And finally, I'd like to thank Katerina, and I'd like to say thank you to all the attendees for being with us during this webinar. And as we always mention, follow us on our social media and stay in touch with our events. We have like LinkedIn, ECU Center for Sustainable Energy and Environmental Engineering, and on Instagram at ECU CSE3. You can also like scan the QR code to learn more about us, and that's it. We finish early today, like 2:42, so we'll have like some minutes free. Thanks again, Katerina, and thanks to the participants, and we will see you in the next webinar. Thank you.
Thank you.